Solutions for perfect problem 6 for math 95. We're asked to multiply this mess right here out. I'm kind of given a hint that the easiest way to do it is to think that the square root of x is really x to the 1/2 power. And similarly, the cube root of x is x to the 1/3 power. And the sixth root of x is x to the 1/6 power. So really what this question is asking me to do is find the product of these two things. And there's a couple of different ways you can do this, but the way that, I don't know, maybe I think is easiest is by doing this thing that we call the box method, where you take one of the two things you're trying to multiply together, so x to the 1/2 plus x to the 1/3 plus x to the 1/6, and you make those kind of the columns, and then for the rows we put the other thing we're trying to multiply together, so x to the 1/2 negative x to the 1/3 and x to the 1/6. And you sort of make a grid, you make boxes out of those two things. Probably easiest to just demonstrate. And so this 3x3 grid has 9 boxes I got to fill out, and in each box I just write the product of that row header and that column header. So for this first one, I got to figure out what's x to the 1/2 times x to the 1/2. Turns out that's just 1, or that's just x raised up to the 1 power. Either because this is the square root of x and this is the square root of x, and the square root of x times the square root of x is just x, or because when you have the same base, you add up the exponents, and 1/2 plus 1/2 just equals 1. To figure out what goes in this box, you have to do x to the 1/2 times x to the 1/3, which is x to the 1/2 plus 1/3. Turns out 1/2 plus 1/3 is 5/6. Where that comes from, maybe down here to the on the bottom, say 1/2 plus 1/3 is the same as 3/6 plus 2/6. If you multiply by this one by 3 over 3 and this one by 2 over 2, I'll have my least common denominator of 6. So now I'm adding together fractions that have the same denominator. Just add up the numerators, 3 plus 2 is 5, and keep the denominator, you get 6. That's where this x to the 5/6 comes from. Similarly, this one will be x to the 4/6. Where that comes from is 1/2 plus 1/6 is the same as 3/6 plus 1/6, which is 4/6. You can make that x to the 2/3 if you wanted to. Sure, I'll go ahead. Well, I'll do that in the next step. X to the 1/3 times x to the 1/2, I already figured out it's x to the 5/6, but now I'm multiplying a negative number and a positive number. The product of a negative and a positive is a negative. So I get negative x to the 5/6. X to the 1/3 times x to the 1/3. I need to add up those two exponents. 1/3 plus 1/3 is 2/3. And a negative times a positive is a negative. So I get negative x to the 2/3 power. And then over here I got x to the 1/3 times x to the 1/6. Then again a negative times a positive. 1/3 plus 1/6. Because I haven't done that one yet, so maybe I'll do it down here. End up getting 3/6, because 2/3 is the same as 2/6, and 2/6 plus 1/6 is 3/6. Isn't that the same as 1/2? Yep. I'll do that in the next step. X to the 1/6 times x to the 1/2. Have I done that one yet? Yeah, 1/2 plus 1/6 is just 4/6. So I'll get x to the 4/6 down here. X to the 1/6 plus x to the 1/3. 1/6 and 1/3 is 3/6. So right here I get x to the 3/6 power. And then finally x to the 1/6 and x to the 1/6. Add 1/6 and 1/6 to get 2/6. Get this. So what that's saying using the box method is that the product of these two things is the sum of these 9 things. In other words, x plus x to the 5/6 plus x to the 4/6 minus x to the 5/6 minus x to the 2/3 minus x to the 3/6, running out of room, plus x to the 4/6, 3/6, and finally 2/6. Get here. You can simplify a lot of those, reduce a lot of those fractions. I got x plus x to the 5/6, x to the 4/6 is just the same as x to the 2/3, because 4/6, I guess I can do it down here, is equal to 2/3. Similarly, 3/6 is equal to 1/2. So instead of writing x to the 5, well, when I get to it, I'll get to it, minus x to the 5/6 minus x to the 2/3. Here we go, minus x to the 1/2, because 3/6 is the same as 1/2, as I said down here, plus x to the 2/3 plus x to the 1/2 plus x to the 1/3. It's just reducing these three guys right here. 4/6 is the same as 2/3, 3/6 the same as 1/2, 2/6 same as 1/3. Now I'll look and see if I can combine any like terms. Well, I got x to the, well, here's the x, got this one. X to the 5/6 and negative x to the 5/6, those just cancel out, that's nice. X to the 2/3 and negative x to the 2/3, those just cancel out, that's nice. X to the 1/2 and negative x to the 1/2, those guys cancel out, again, nice. So all I'm left with is an x to the 2/3 and an x to the 1/3. So my answer simplifies to this, which is pretty nice. I don't know, I've seen uglier, I guess. So you get here, and you think you're done, but then you go up and see that, oh, I'm supposed to express my answer in radical form. So just like I originally changed the problem from all these radicals into exponents, now I got to change it from the exponents back into the radicals. Instead of x to the 2/3 power, I'm going to say that's the cubed root of x squared. And instead of x to the 1/3 power, I'm going to say that's the cubed root of x. And this right here is what I'm going to give as my final answer. And so I will end this video here.